All right, welcome to Friday with our stats class. I know you guys missed out. No video yesterday. Sorry for everyone at home that was disappointed. That's okay. We're back today, and we're ready for our fourth period. So we have a problem that is talking about looking at this distribution of AP scores from the 2006 exam. And you can see that the range of scores is 1, 2, 3, 4, or 5. And then we have a percentage of students for each one. I already had you guys write down the mean and the standard deviation. Could someone please tell me those again? What's the mean?
2.859.
Excellent. So the average score is a 2.859 with a standard deviation of 1.324 points. Okay, thank you. So we are going to think about if that is coming from a population. Right, that's every student in the world who took the 2006 AP Stats exam. Is everyone imagining that? Kids all over the world take this test. Okay? So imagine these kids, 2006, that's, wow, over 10 years ago. Okay? And that's real data. That's actually what it was in 2006. Okay? So millions of students. So the reason I use mu and sigma is because these are called what? What are those called when I use those symbols? Think alliteration. Think alliteration. You know what alliteration means? Like, okay, yeah. Like Sally sells seashells by the seashore. That's alliteration. Population parameters. These are called population parameters. This is not a sample of data. This is the whole population. It's every kid and their score. Which is why I use the symbols mu and sigma. If it had been from a sample, what symbol would I have used for my average? If it was a sample statistic, what symbol would I have used? We're not using proportions, right? This is not a proportion. Y bar is right, Yasmin. Y bar. And what would this symbol have been? Instead of sigma, which is the Greek letter S, it would have been the English letter S. All right? So that's the difference. Population parameters, sample statistics. So imagine that if you have this pool of students, all the students are in this pool and they're scored, not literally, right? All of them are in this group. And I'm going to take a sample of 40. A sample of 40. Do it over and over and over again. I can create a sampling distribution model for what I think that will look like if I were to actually do it. But am I going to do it? No. Now, before I do that, I need to do two things. What's the first thing I have to do? Make assumptions. And the second thing? Check conditions. So the first assumption is the independence assumption. Okay. Just like I've done in the past, treating this like a college course, which means as the professor, I'm not going to write everything down because I'm lazy. That's your job. You're the one paying. Okay? So what would I write down if I was a student in this class for a sentence about what I'm assuming about independence? Very good. If I take a sample of students and I look at one student's score and I see it's a 4 or a 2 or whatever the number is, will that affect the next one that I pick up? No. So one student's score does not affect the others. Now, can anyone think of any ways that a sample of 40 students Can anyone think of any way that a sample of 40 students, you might be worried about independence? Yes, Jace.
Or by chance from the same school?
Absolutely, Jace. Very good. If it's just out of nowhere, they said, oh my gosh, look, all these 40 students are from the same school or the same school district, right? That might cause me to worry a little bit about independence. Is that likely out of millions of kids to have even one from the same school? Probably not, right? It'd be very unlikely. So I'm not worried about independence. What can I do to make me feel a little bit better? Check some conditions. What condition am I going to check first? The randomization condition. I think I heard somebody say the other one. What's the other one I'm going to check? 10% condition. Peter's here? Come in, Peter. Excellent. I knew we'd meet this week. Hello, sir. That's for you. We're doing the last 2 pages. Thank you. Don't worry, all this stuff's online. Busy weekend ahead of you of YouTube videos. Don't forget to like, comment, subscribe. All right. What about a sentence about randomization? A sentence about randomization. Do you see anything in the problem that makes me feel like they randomly sampled? Not trying to trick you. It says what? Random samples of 40 students. So I would just write, my sentence would say, we're taking random samples of 40 students. Or you can just write, random samples of 40 students. Good question. If it doesn't say random, then you're going to say, I'm assuming that they randomly sampled. Now I'm hoping, Yesenia, that they do mention, bless you, something about randomness. What about the 10% condition? We can do a little work there. What's my sample size? 40. What do I do with my sample size? All right, and what is 40 times 10? 400. So ask yourself this question. Do you think there are more than 400 students who took the 2006 AP Stats test? Absolutely, right? There's more than 400 that took it in the city of Houston. All right? So we're talking about the world? Yes, way more. So what we're saying here, and the statement I would write, is my sample size is not too large. My sample size is not too large. And when you're watching this video this weekend, as I know many of you will, go ahead and pull up while you're doing it the key that I'm going to post to Classroom so you can see the statements that I'm talking about. Because I did on the key, I wrote it. Wasn't lazy on the key. I wrote it as if I was a student. Okay? Questions on the independence assumption and the associated conditions. Okay, we just said our sample size is not too large. Now I'm going to make a statement about my sample size being not too small, very good, or large enough. So I'm going to write down the other condition, the other assumption, the sample size assumption. So what's the statement I'm writing there? Who wants to give it a try? Aiden, you go try? The assumption for sample size? What are we assuming about our sample size of 40? Very good. You can write, it's not too small. The words I'm going to use that mean the same thing are, it's large enough. 40 students is a large enough sample. Or my sample size of 40 is large enough. Something like that. Or as Aiden said, 40 is not too small. Now, we don't know if that's true, so we check the large enough sample condition. Okay, now here's where it gets a little tricky. Did it mention anything in the problem yet about what the population distribution looks like? It didn't. All right, so if the population distribution looks unimodal and symmetric, then I don't really care what my sample size is. But if my population distribution showed any skewness or possible outliers or gaps or bimodal, then I would need to think, is 40 large enough to kind of get past that? So since it doesn't mention anything, I'm going to say, I'm assuming that the population distribution looks normal. And I have no reason to believe that that's not true. If I think about the scores on an AP exam, I bet it would roughly resemble a bell curve. You have the majority of people getting around 3, less people getting 1s and 5s. Sure. What I'm saying is, I'm hoping the problem mentions something about what the population distribution looks like. It doesn't. So what I would do is I would say, I think the population distribution would look normal. So if I think that, Yesenia, then I don't really care if 40 is too small or too big. Like, I'm not worried about it. Okay. Once we do that, we're ready to make what? The curve, the model. Let's make it. Was it not clear that I was writing small? Sorry. I was trying to write small. Okay. Now, if we were making this curve, this model, using population parameters like we have in part A, then I would use mu and sigma in part A. But I'm not going to do that. I'm going to use a different mu and sigma. My mu is going to be the same, 2.859. Do you guys remember the formula to find the new sigma? It's sigma over the square root of n, the sample size. So in your calculator, which everyone should have one, I want you to do the fraction, 1.324, that's the population standard deviation, so the fraction, 1.324 divided by the square root of 40. And it looks like, if you guys can confirm, 0.209. Did other people get that? Excellent. All right, so I'm going to use that to make my model. So right down the middle is going to be 2.859. How many standard deviations do I care about moving? 3 in both directions. Right? I know sometimes it's hard because you think about your favorite band and you only want to go in one direction, but you got to go in both. Man, I love that band. All right, so let's take 2.859. Let's go ahead and add and subtract our standard deviation of 0.209. There we go. 2.859 plus 0.209. Okay, so I got the first one is 3.068. Anyone confirm? Okay, the next one, 3.277 plus 0.209, 3.486. Go the other way, minus 0.209. Go the other way. So when I finished these numbers, my brain immediately noticed that the lowest value didn't even get below 2. Do you guys see how it didn't even get below 2? And the highest value didn't even get to 4. So if I have a random sample of 40 students, and you tell me that the average of that random sample is a 4 or a 2, then immediately I'm thinking it's unusual. All right, because it's past those numbers. All right, which kind of makes sense. If you're saying the average score is a 3, we would expect our values to be close to 3. All right, now, what's nice is I'm not going to make you write that statement. All right, so you don't have to write the according to the model, da 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 da. You don't have to write that. All right? Are there any questions about this model and the process? And I know it's a long process. I really do. Trust me, I understand. All right? I need you to understand the process because what we're going to do next week follows the same kind of outline. Everybody good? Can we move to part C? Okay, let's move to part C. Everybody has it down? All right, because it's going away right now. Okay, part C. Let's have Galileo. Would you mind reading part C for us? Thanks.
Teacher has insisted students preparing to take the AP exam discussed above. Though they were obviously not a random sample, he considered his students to be typical of all the national students. What's the probability that his students will achieve an average score of at least 3?
Okay, so right there, the teacher is kind of saying, making our job a little easier. We're not going to check any conditions or make any assumptions for this problem. This is a problem that I would call application problem. All that work we just did for 15 minutes was to set up this problem. Okay? So when it says, what's the probability that his students will achieve an average score of at least 3, I'm going to compare what I think is going to happen compared to a model. But it's a different model than we just made. How is it a different model than what we just made? What is the one change that Galileo read that tells me I cannot use that model I just made? 63 students. Because that model I just made was about sample sizes only of 40. You guys see how that one little change means we can't use it? Don't worry. We don't have to make the curve. We can still do this without making the curve. So let's go ahead and try. The first thing I want you to do is write down that we are going to standardize this value, which means I need to find, a z-score. It's been a long time. Okay? So, we care about this teacher's class having 3s or higher as an average. So I'm going to standardize using a formula that has a model. All right? So a model. And we're talking about doing minus mu, so it's a model, and over, and what do we divide by? We always divide by when we standardize. It's been a long time, since October. Somebody said it. Sigma, the standard deviation. But oh my goodness, guys. Hold on. Hold on. Oh man. I wrote sigma, but we also learned that if we're going to use a model based on a sample size, I need to take sigma and divide that by the square root of n. I know, right? It's all coming together. Now, what symbol am I going to write here? This is called a sample statistic. And it's an average. It's a class average, so a sample statistic. Y bar. So, let's fill in some numbers now. Should I change colors? Yes. Purple. I care about this teacher's class average being 3 or higher. So I'm going to put y bar in at 3. Let's standardize just 3 and go from there. Minus, what is the average score that I think applies to a typical class of students for the AP exam? What have we already talked about in our other model? What was it? I think it was longer than that, right? 2.859. That's my best guess, guys. If I don't know what the typical average is, I'm just going to use what the average is for all of the students, which you wrote down at the very, very beginning of this class is 2.859. Divided by, what's the sigma from all of the students? So that's sigma divided by this particular case, how many students for a sample? 63. So take your calculator. This is fun because it becomes like almost like you're watching the movie Inception, where you have a fraction within a fraction. No? Some of my viewers will get that joke, but I guess it's a little old. Let's see if we can get the same thing. Okay, I have an answer. Anyone else? 0.845 is what I have. Now, once I standardize, I am going to imagine that I made this model. Did I make this model? No, I didn't make this model, but I'm going to imagine that I made this model. There's my model. Where is 0.845 on this model? Where is that z-score of 0.845? Where is it? It's not in the middle. In the middle would be z-score of 0. No, to the left will be negative. So it's to the right. But is it very far to the right? Because remember, this is 0, and then it goes 1, 2, 3. So 0.845 is not even going to be 1 standard deviation to the right. So there is z equals 0.845. Obviously, you should write on this page, even though I'm not. Please write on the same page. Now, there was a key phrase in the problem that's going to tell me where I should shade. There was a key phrase in the problem that's going to tell me where to shade. At least. Very good. You see, at least? That means 3 or higher. Right? At least 3 is 3 or higher. So which direction am I going to shade if I want at least this number or higher? To the right. And your brain should be, hopefully, firing on all cylinders and saying, wow, I feel like we did this before. So we did. But I'm going to make your life easier. Pull out your phone. I did this with Excel last time, and I thought, why? We all have cell phones. Pull out your phone. I need to find the probability that my z-score is greater than or equal to 0.845. If you type into a browser, so open up your browser, and type in zscorecalculator.com. Yeah, that's right. Somebody made this website. And that's right. I found it. zscorecalculator.com. Now, if you get a virus, that's my bad, okay? But you should be okay. Don't click on any of the other stuff. zscorecalculator.com. Is everybody there? All right, because this is going to go away. So this is going to go away. So make sure you tell me if you're still writing. It's going away. Bye-bye. See ya. Because now I'm going to get the answer. So I'm done with my work, done with my math. Now it's time to find the answer. zscorecalculator.com. Go ahead and bookmark the page. Why not? Man, it's tough Friday. Tough day. All right, it's going away. Bye-bye. Here we go. zscorecalculator.com. Does yours look like this, just smaller? Okay. Now, do you guys see where it says inputs? I see inputs. There's 6 options. Which one am I going to pick? The right. Very good. So select right. Now, right now, it's giving me the probability of my values being to the right of a z-score of 0. And you can see that that answer is 0.5 or 50%. Is my z-score 0? No. What is my z-score? 0.845. So where it says left z-score, you should type in... Is it right z-score? My bad. Right z-score. My fault. You should type in point... Can I not type? Wait. Keyboard. Yes. No, that's not coming. Okay. Oh, no way. Oh my God. That's so sick. Okay. Why didn't it calculate? Do I have to click away from it? Did yours calculate?
Yeah.
Okay. Wow. Mine didn't. Sad. Why didn't that work? There we go. Can I delete that? Okay. Man. Yeah, but I think it's just going to go away. Yeah, it did. Anyway, you can use it. And it gave you the answer. Yeah. Oh, you're like in the middle. We're like right in the middle of this thing. So what's the answer?
20.4.
So 0.205? So you have that work right there?
It's 200,454.
Oh, so 0.200. Okay, sounds good. So 20%. 0.200. So we're telling this teacher that the likelihood that his students will achieve an average score of at least 3 is about 20%. So not likely. Everybody good on that question? You can go if you like, because this is kind of a stopping point, but not really, because I'm going to keep going. But we're going to a new question. So it's up to you.
Is it like new?
I mean, it's different.
Okay.
So unless you're going to have an accident, I wait. Here we go. Number 2. Now, I want to tell you guys right now that this problem is different than what we did just, 20 minutes ago. And also, it's different than what we did together on Wednesday. All right, so let's read this problem, see what I'm trying to talk about. All right, let's go with Aiden. Do you mind reading number 2 for us, please?
34% of Americans say that math is the most important subject in school. In a random sample of 400 Americans, what is the probability that between 30% and 35% say that math is the most important subject?
All right, well, it should be 100%, obviously. But, thank you. Does anyone see why I'm making a big deal about this being different, a different problem? There was something that Aiden read.
Is it between 30% and 35%?
And it has to do with that because now, if you notice, I'm giving you percentages, so your brain should be thinking, da 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 da. This is talking about proportions. We just spent the last 20 to 30 minutes talking about averages, the average AP score. Now we're talking about proportions. This is what we did on Tuesday. So what I'm going to do is I'm going to standardize 0.3 and standardize 0.35. I need to standardize first. And when I say standardize, I'm hoping that your brain knows that I mean I'm going to find a z-score. So let's see if we can find the formula here, right in the middle. So I'm going to use it for both. Z equals. Now again, you're going to be wrong if you use the formula that we just used because that was for means. That was for averages. So for proportions, it's different. I need to subtract the mean of a proportion, which is P. Do you remember what P represents from Tuesday? It's been a while. I think somebody said it, yeah. What is it? Population proportion. The population proportion. And they actually gave it to us in this problem. What is the population proportion in this problem? That's a sample size. 34% of Americans say that math is the most important subject in school. That statement is only there to give you P. So P is 34%. I tried to trick you because I gave you 34% as a word or words. All right? I didn't give you as a number, so I got you. Divided by, are we divided by sigma? No, because this is not for a population. So we have to divide by the sample, or excuse me, by the formula we used on Tuesday. Anybody remember? I know it's been a while. It's a square root of P times Q over N. What? Welcome back. Tuesday. So now the question is, what is the sample statistic I write here? Don't say Y bar, because it's... Oh, yeah, it's called P... Don't say carrots. Hat is the carrot. P hat. That means the sample proportion. So this is the formula we're going to be using. Now, here's the hard part about this class. I'm going to give you the formula for a standard deviation for this proportion. But am I going to give you all of this? No. See, that's the hard part here. All right? You might be thinking, oh, you said you're going to give me the formula. Yes, but just for like individual pieces, not clumping it together. Okay? So let's write, I know, right? So mean. Let's write down how we're going to do this. Z equals, so 0.3 and 0.35 are what we would call our p hats. Okay? So that's going to be 0.3 minus, what's my population proportion? 34%, so 0.34 over, these are separate things. We need to find two of them, one for 30 and one for 35. Because remember you said it says between. If it says between, that means I need to find the area in between these two values, which your z-score calculator will do. Over the square root of PQ, oops, sorry. Come on, erase. Okay, it's not erasing. That's supposed to be 0.34. What if I do that? Why is the eraser not working? That's 0.34, sorry. And then what's Q going to be? Which is? What's 1 minus 0.34? 0.66. Over 400 is the sample size. Very good. Now, I know this is a lot, right? I totally understand because you've never really done this before. But look, I want you to think in your brain that you're going to copy this and you're going to paste it over here with one change. The only change is 0.3 is replaced by 0.35. That's it. So I know it looks like a lot of work, but it's the exact same thing over here. But 0.35 replaces the p hat.
Wait, what did we say, 0.34?
0.34 at the very beginning of the problem is the p, our population proportion. So p equals 0.34. Because they're telling us that's from the population of all Americans. So imagine they went around and asked every single American, what's the most important subject in school? Is that really feasible? No, right? That's why in our world, outside, we have things called polls, where we try to sample a representation of all Americans, and then we use that number to make conclusions about Americans. So if you're ever hearing any stats about Americans in general, it's not because they asked everybody. It could be negative. What does it mean if it's negative? What does it mean if your z-score is negative? All it means is that your statistic is below the average. Your statistic is below the population proportion. Is that the negative one? So I heard negative 1 point. Can you go for, like, do one more after? What's after the 9?
6, 8, 8.
Okay, so 6, 8, 9. Perfect. Thank you. And what about, has anyone done the positive one? All right. You're going to have to do this, like, on a quiz at some point. So you might want to give it a go. I think these calculators are really nice. I like the n over d function. It's such a cool feature that I did not have growing up. I know, tough times. What is the C-score for 0.35? I got 0.422. Anyone else get that? Susanna said yes. Anyone else besides Susanna?
Yeah.
Yeah? Excellent. Very good. More people out there trying. Okay. So now I want you to sketch what this looks like. We're saying if this is our curve, we need to put a line to the left of 0 at z-score equals negative 1.689, and to the right of 0, z equals 0.422, and I'm shading between. The word said between. Now, if you'd like to write down what that notation is, it's the probability that your z-score is less than 0.422, but greater than negative 1.689. That's how statisticians would write that. Once you have this all written down, where are you going to go? Z-score calculator on your phone. And let's decide which one we're going to pick. Now, this stuff is not familiar to you. So if I was sitting in this seat trying to comprehend all of this, which is not easy because it's not familiar, what would I do over the weekend? I would practice. And I'm going to give you a piece of paper to practice with before you leave today. So I would try to do those problems. All right. Can I go to the calculator? All right. I don't know why I'm going because I know it's not going to work for me. So. Okay. So it would work if I had the little keyboard, but it disappears in this room. Okay. Now, on the first one, we picked right. Out of those 6 inputs, what option am I going to pick? So I'm looking at the middle ones because I shaded in between. So is it middle equal area? Were they the same z-scores? That's what equal means. Same z-scores? No, they weren't. So I need to click middle, different areas. All right, so click middle, different. And then in your left tail, you're going to put, what is it, negative 1 point. Is this worth it? Probably not. At this point, I'm halfway there. Now I am. This was not worth it. But now I can't stop. I'm going to round too. I'm sorry. Okay, and this one's a little easier. 0.42. So my number's not going to be exactly as yours because I rounded. I don't recommend rounding. There it is. So something around 61, 62%. What is the actual answer? Oh, man. Was I way off? Did I do something wrong? Oh, man. My bad. Oh, did you guys put in middle different areas? Oh. Yeah, so that's... I should have done that. Huh. Because that's wrong. Oh, man, do I have to completely scrap this? Sad. Well, whose did it? Did it shade to the right of 0, though? No. Oh, it did, yeah. Hers did. Did you do something different? Try again. Try typing into the...
63.
Yeah, that's the answer. It's like closer to like 63%. What is your number?
79.
Huh. That's weird. All right, well, I guess I'm going to have to go back to a different... Darn. Okay, well, try this weekend, Z-score calculator, see if it works. But Ultimately, it should be around 63%. All right. Almost there. Last one. Yes, it's a multiple choice question. All right. Let's go with Yesenia. Read number 3 for us.
Is estimated that school
CO2.
levels average, oh wait, it's in my paper, I will.
It is in your paper.
Is estimated that
Lol.
CO2 levels average 1,200 ppm with a standard deviation of 300 ppm. In a random sample of 300 schools, what is the probability that the mean CO2 level is more than 1,000? A level at which some researchers feel will cause drop in academic.
What? My brain thought this was the absolute value of 0. Hashtag math teacher. Okay. I was listening, Yesenia. Thank you for reading. So, first thing I want to clarify here is let's figure out what are population things and what are sample things. So, this is talking about averages, right? You see here it says average. What is my mu? My population average. 1,200. What is my population standard deviation or sigma? 300. So when I think about the formula that we used, the formula we used a couple problems ago was y bar minus mu divided by sigma over the square root of n. So immediately, when I look at my answer choices, I can cross out 2 of them because they don't have mu in the right spot. Do you see how C and D do not have mu in the correct spot? Mu needs to be after the subtraction symbol. Now, what's the difference in A and B? Well, one of them only divides by sigma, and one of them divides by sigma over the square root of n. And which one do I want? Over the square root of n. So that's why it is A. But if you put B, that's the best wrong answer. But it's wrong because we're talking about a sample of 30 schools. All right. Thank you guys for watching. I hope you enjoyed this video about sampling distribution model questions. And tune in next week when we talk about confidence intervals.